All right, so this is advanced geometry topics for sophomores. Okay, I'm going to explain each of the theorems, and then you guys will try to solve some problems with this. The first one, it's called Brahmagupta's formula. Basically, if you have a cyclic quadrilateral, meaning that there's a four-sided shape inscribed in a circle, you can find the area of it with simply knowing the sides. If you have AB, or A, B, C, D, okay, with the length for each of the sides, you can find the semi-perimeter. Half of the perimeter, that's represented by S, A, B, C, and D added together, divided by 2. This is the formula for the area, okay? So, half of the perimeter minus one side, half the perimeter minus the other one, the third one and the last one, take the square root of that, that's going to be your area. The same thing works for a triangle. So why don't you guys add this to this packet? Let's say you have a triangle with sides A, B, C. This one is called Heron's formula. And that's the square root of half of the perimeter times half the perimeter minus A, half the perimeter minus B, half the perimeter minus C. Since we're talking about triangles, I'm also going to add the area for the equilateral triangle. Anyone remember that?
It's square root of 3 over 4.
Side squared root 3 over 4. And then hopefully I don't have to make you remember the base times height divided by 2. So right now this seems very tricky because it's out of context. We don't have any problems. But as we start doing practice, you're going to find a problem like this. This is the formula that I want you to go back to. Now, point to a line. If you have a line and you were graphed on the coordinate plane, and we pick a point, let's say this point is x1, y1. What Katie was saying, you could actually find like the slope of this line, do the perpendicular slope, but that's actually more work. There is a formula that allows you to find the distance here. What you need is the equation of the line, and you need to write it in standard form, and you actually almost like make it equal to 0. So everything has to be moved over. A has to be positive. Should I do an example of how to do that? So let's say you were given an equation like this, 1/2 x minus 5. How would you rewrite it so that it's like that? What's A, what's B, what's C? Well, if it's standard form, you want to make it so that it's fractions, so you actually multiply everything by 2. So it's 2y equals x minus 10. Then we subtract the x, and then we're going to add the y, so let's actually divide by -1. And now move this, so x minus 2y minus 10 equals 0. So from here we would be able to pick out that A is 1, B is -2, and C is -10. Do you remember that from algebra? So that's just like a side note right here. So that's your A, B, and C. And now, eventually, I'm going to ask that you memorize this formula. A times x1, which is the point, plus B times y1 plus C, and then on the bottom, square root of A squared plus B squared. And on the top, you're just going to take the absolute value. Again, if you're going to be doing a problem and it says find the distance from this point to this line, go and try this formula. Next one, area of a triangle given the vertices. Now this is a little tricky. Like, if I gave you a triangle, and then I gave you that this is x1, y1, x2, y2, x3, y3, how would you find the area? Well, one way would be to find the distance between them, and then you can go back and try this Heron's formula, right? But that's a lot of work. There is a formula that works like this. This actually also works on your calculator because there's a shortcut like this. How do you remember what to multiply? Like you do x1 with y2. It's very tricky, but you can memorize it. I want you to add this in, let's see, in here. You can do it using matrices. The area could be found by multiplying the following matrix, or actually the determinant of the matrix. I don't know if you guys remember. Has anyone heard of the determinant of a matrix? Do you have a calculator? Show me your calculator and then I'll show you how to do it. Here's how you write the matrix though, because you need to know how to do that. You simply look at these and you do x1, y1, and then the number 1. x2, y2, and then the number 1. x3 and y3 and the number 1. This is a calculator meet, so technically you could do that using a calculator and you could do it by hand. So does someone have like a graphing calculator? Yeah, so you might be at a disadvantage.
I have the graphing.
You have it? Okay, so do you know how to enter a matrix?
Yeah.
You go under second matrix and then you go under edit. You hit enter on it. Then we enter 3 by 3 because it gives you all the values. So let's pretend, like give me some numbers. Let's say this is 2, 5, this is 6, negative 3, and this one is like negative 8, negative 6. Okay, so we're just going to make up some numbers. How would we do that? So well, x1, y1, we just kind of list everything. So it's 2, 5, and then 1. On the next one, it's this, 6, negative 3, and 1. This one, negative 8, negative 6, and 1. So that's our matrix. So now you quit out of this. Now to find, because this is really, it should say the determinant of that matrix. That's what these bars mean. Don't worry about understanding because that's not important, but you just need to know how to find the determinant. You go second matrix, you go under math, and it says the determinant. Enter. Now to bring up the matrix A that we've just put in, you do second matrix. Matrix A, you just hit enter on it. There it is. So if I hit enter, this is the determinant. It's just a single number. So to find, this is like kind of like a trick almost. Because what the determinant did was actually performed this calculator. Like multiplied these numbers. Like really you could just plug in the numbers. Like this could be 2 and this is negative 3. Multiply it. So you could do it by hand. Right? Plug it in and figure it out. It works out to be negative 124. So what would be the area? 1/2 of the absolute value of negative 124. So what's this? 62? So the area of this triangle happens to be 62. So that's a very neat trick, and especially if you have your calculator, if you practice putting in the matrix, you're going to be fine. Good? Moving on. Stewart's theorem. This looks very familiar because when you guys did like medians, like altitude, so this is another one of those. If you have a triangle with a line drawn right here, this is not an angle bisector, like any random line. Here's the Stewart's theorem that you can use. And the problem that I could give you with this, like I would give you this side, this side, this side, this side, and this is missing. And I'm going to find this missing side. So this whole thing is C, because it's across from capital C. So you just do A squared times N plus B squared times N equals C squared, the whole thing, or never mind, I'm sorry, C times D squared plus C times N times N. It's a little tricky when I just kind of explain it like this, but today on the practice, there's a problem where you're going to use this. Okay? So just remember there's a triangle with one line. It's Stewart's theorem you're going to use. Ptolemy's, I'm not even sure if I'm saying it. A quadrilateral is inscribed in a circle only if the following is true. AC, so what's that? That's the diagonal, times BD, the other diagonal, is equal to the product of the opposite sides added together. AB times CD is plus AD times BC. So if you see a picture like this, quadrilateral inside with diagonals, that's probably what you're going to be using. Good? Does this look familiar? Those of you in geometry. Kind of like law of sines, but flipped. This, if you have a triangle and you draw a circle around it, you can actually find its diameter using kind of like the flipped law of sines. So if D represents the diameter of this circle. A divided by sine of A. Now remember, if this is capital A, this is little a. This is B, this is little b. This is C, this is little c. Right? And you just find the diameter like this. Next one, in radius and circumradius. You guys have learned about an inscribed circle, right? That's the radius. It makes a right angle here. How do you find that radius? You simply take the area of the triangle divided by half the perimeter. So if you have a problem like this, you might have vertices. Now you know how to find the area of the triangle using a couple of different ways and then divide it by half the perimeter. Same thing for the capital R, stands for the circle that's around the triangle. So the triangle is now inscribed. It's called the circumradius because it's around, in radius is inside. So for that, you just multiply the three sides and divide it by 4a, 4 times the area. And this actually should be in parentheses here. Good? Last two. Those are the ones that, again, if you see a triangle, this looks similar. Like this could be a median, right? They could be angle bisectors. But you actually don't know if these are just random lines, but they happen to be intersecting. Only if the following proportion equals to 1. BD over DC. It's kind of like you walk around the triangle. This over this times this over this times this over this equals to 1. So a type of problem that I could give you is like I could give you all of the sides, but this could be x. So you would just substitute. One of these would be x. You would have to multiply it, blah, 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 and find x by setting it equal to 1. This is called the Menelaus. This is Cheva. It's called the Cheva's theorem, Menelaus theorem. This one looks, it's also the same idea. You have a triangle, ABC, and you have F on this side, E on this side, and D is on the extension of BC. So actually, the picture at first looks like this. It's A, B, C. And then I put a point here, and I put a point here, and I want to put another point on the extension here. And the only way that these 3 points would be on a line, so that's why points D, E, and F are collinear, only if it's the same kind of setup, but now it's equal to -1. So now it's BD over DC. Now this is tricky because do you see how DC is labeled kind of like backwards? DC. The reason this is negative, and it will depend on the problem, this value sometimes, like if I say that this is the length is 6, you actually use the -6 because you're using the part on the outside, okay? But if in the problem it tells you use only positive values, then you would make it positive and make it equal to +1. So you would go BD over DC times, and now you just go back to the triangle. EC times EA times AF over FB, and the whole thing equals to -1 or +1. Again, how are you going to use this? Right now it seems kind of like, oh, what's the point? When you see a problem like this and you see, oh, there's a triangle and a line extending on the outside here, you probably should be applying the Menelaus theorem. We're okay? All right, let's see if we can do some practice.